All right, this is the back side of the week 16 weekly review. For the first question, we're being asked to solve that system of equations graphically. Both of those equations are in standard form. So for the first equation, I'm going to graph that one in black. I'm going to find the y-intercept. I'm going to put a 0, I'm going to find the x-intercept. I'm going to put 0 in for y and solve for x. So if I put 0 in for y, be very careful on this. We have -3 divided by 9. It's not 9 divided by -3. So this is actually -1/3. Then I'm going to put 0 in for x and solve for y. So y would be -1. Now, if you're not feeling super comfortable with graphing that fraction, what you could do, I'm going to go into the margin space over here. You could get this equation into slope-intercept form. Subtract 9x from both sides. 3y equals -9x minus 3. Divide everything by 3. You have y equals -3x minus 1. So if you wanted to, you could use slope-intercept form, or if you feel okay graphing a -1/3 for your x-intercept, that's okay. I'm going to go ahead and use slope-intercept form. It's going to give me a better idea of more specifically where my line is. So my y-intercept's -1, my slope is -3, so I'm going to go down 3 and right 1. And I'm going to continue with that pattern so I can get a nice line all the way across my graph, because I have no idea where these two lines are going to intersect. So there's the first equation. If you want to use the x, y-intercepts, you can. The x-intercept is not awesome. It's -1/3. So graphing with the intercepts, it might not give us a super accurate line. And since we're going for an intersection point, we want to be as accurate as we can. Let's see what happens with the second equation if we try graphing with the intercepts. If I put 0 in for y, x would be -2. 0 in for x, y is going to be 4. So those intercepts work out much nicer for us. X is at -2 and y is at 0,4. So if we draw in our line, it looks like the solution or the intersection point is at -1, 2. If you would like, I always like to do a quick check. Substitute x and y into both equations. -9 plus 6 will give me -3. 2 times -1 minus 2 equals -4. So -2 minus 2, -4 equals -4. That checks out. There's our intersection point. The next 3 questions, they go together. We're going to use that same data set for the next 3 questions. We're going to use our graphing calculators to do this. If you've never used a graphing calculator before to find the correlation coefficient, that's okay. I'm going to walk you through that right now. When you turn on your graphing calculator, the first button you're going to press is the stat key. And we're going to choose option 1. We're going to edit. Use your arrow keys to highlight list 1 like it is on my screen. Press the clear button, press enter. Arrow over to do the same thing for list 2. Have list 2 highlighted like it is on my screen. Press clear, press enter. Arrow back over so the first entry in list 1 is highlighted, and we're going to enter the first data set. So we're going to have 20, then just press enter. 24, press enter. 48, 60, 76, 88, and 96. Use your arrow keys to get to the top of list 2. 146.6, 151.3, 173.2, 194.2, 221.5, 225.8, 227.7. Always just do a quick double check. This data set is not super large, so make sure that all your values are entered correctly. Otherwise, you will end up with the wrong correlation coefficient and the other pieces we're going to look for as well. So once you have your data set entered into your lists, you're going to press the Stat key once again. You're going to arrow over to Calc. I know there's lots of different things on this menu. The only thing we have to worry about is option number 4. You can either arrow down to number 4 like I did and press Enter, or you can just press number 4. Now, if you have an older calculator, you are just going to have linreg ax plus b appear on your screen. Just press Enter. If you have a screen like mine, make sure list 1 and list 2 are there for your X and Y list. Frequency list cleared out, store reg EQ cleared out, highlight calculate, and press Enter. This first question asks us for the correlation coefficient. That is just your R value. So the very last thing listed on your screen, the plain R, and it's customary to round that to 3 decimal places. So 0.987. So R is approximately 0.987. Then we're asked to give the line a best fit for the data. Those values are also on our calculator screen right now. We're going to have Y is approximately, and then we see up at the top of our screen we have Y equals AX plus B. That's the form for our linear regression equation. So we're going to take our A value, again, round to 3 decimal places, so 1.156. Sorry guys, I keep clicking on the wrong one. 1.156, and the X goes with that. And then the B value is 123.410. So 123.410. That's our line of best fit. Last question in this row. If X represents the number of years after 1900 and Y represents the winning discus throw in feet at the Olympics, interpret the meaning of the slope and y-intercept of the line of best fit. Okay, so our slope is 1.156. That's our slope. And remember, our slope is the change in y over the change in x. So y is the winning discus throw in feet. So y is feet. And x is the number of years since 1900 or after 1900. So each year after 1900, the winning discus throw is 1.156 feet more. So that's the change. So winning throw increases by 1.156 feet. per year. Then the y-intercept, I'm going to go over to this box over here for the y-intercept, is 123.410. So the y-intercept, remember, x is 0. So x represents the number of years after 1900. So this would actually represent the year 1900. And then this is the winning throw. So 123.410 feet is the winning throw in 1900, or in that year. In the last row, we're just looking at reviewing some of our exponent properties. Oh, we're missing a parenthesis here. Actually, we don't even need one. All right, the first thing I need to take care of are all of my power of a product rules. So all my exponents outside the parentheses. So in the top, we would end up with 3 to the third x to the third. In the denominator, 9 to the second x to the second times 3 to the negative first y to the negative first. I'm going to go ahead and do a little bit of simplifying. 3 to the third is 27. 9 to the second is 81. And the negative values are going to pop up top. So we have a 3y that's going to be in the numerator. 27 times 3. So these two pieces up top would give me 81. I have x to the third y over 81x squared. The 81s will simplify. X to the third over x to the second, I subtract those exponents, I get x to the first, and then I just have a y. The second question, this last row. Anything to the 0 power does equal 1, but keep in mind the 5 is to the first power. The only base to the 0 power here is the x. So 5 is going to stay put. X to the 0 power is 1, so 5 times 1 is just 5. Third question in this row. Let's get rid of our powers on the outside of the parentheses. So for the first set, we're going to have a 3 to the third, x to the 6th. We're going to multiply the exponents. Then we have a 4 to the third, x to the negative 6th. 3 to the third is 27. We have an x to the 6th. 4 to the third is 64. We have an x to the negative 6th. Then I need to do 27 times 64. I don't know that off the top of my head. $1,728. Then x to the 6th times x to the negative 6, we would add those exponents and we just end up with 0. So my final answer is 1,728. All right, our very last question. Everything's being multiplied together. So when I'm multiplying, I can add exponents with the same base. So the 2 is just going to stay put. X to the second and x to the third would give me x to the 5th. Y to the 4th plus y to the negative 6. Or excuse me, y to the 4th times y to the negative 6. I would add those exponents and get y to the negative 2nd. Negative exponent, we need to move that to the denominator. Everything else stays, just the base with the negative exponent moves. So that completes our Algebra 1 weekly review for week 16. Please feel free to rewind, pause, Ask questions wherever you need.